Hi, this is Wendy, and in this video I'm going to introduce you to arrays, which is how we store lists or collections of data in programming. In many applications, you often need to keep track of lists of data, not just single values. For example, you might need to retrieve a list of student grades so that you can calculate the average and then print a report of any students who are above or below the average. Or you might need to keep track of the various player characters in a game and all of their different statistics. One easy way to keep track of lists of data is by using an array. In this course, we're only going to cover basic arrays in Java. If you're already familiar with collections like the array list or hash map, keep in mind that we won't be covering anything in the Java collections framework until term 2. For this course, you will only need to work with regular arrays as defined in the notes for this lesson and in chapter 7 of your textbook. So why do we use arrays? They offer more convenience and make it easier to process lists of data. Take a look at this example from your notes. If you go into the arrays notes and scroll down below the list of terms and stuff, there is the why we use arrays, and there's some pseudocode there. So this example creates a constant for the number of courses. It's currently defined as 4, and then they declare variables for 4 grades, and also an average for the average grade. Then we have 4 sets of prompts asking the user to enter one of the 4 grades. Next, we calculate the average by adding the 4 grades and then dividing the sum by the number of courses, which remember is 4. And then lastly, we calculate the average and then we test each of the 4 grades to see which ones are above the average. This code works, however, it's not well written. For example, what if the student was taking 6 courses instead of 4? Take a moment to look through this pseudocode. Go ahead and pause the video and make a list of all the different parts of the code that would have to be modified to work for 6 courses. Then resume the video and we'll discuss the answer. So looking at this code, the first obvious thing we would have to do is to change the num courses content to have a value of 6. Then we would have to add 2 more grade variables to hold the 2 new grade inputs. And then we would have to add 2 more sets of prompts to retrieve those 2 extra grades from the user. Then we would have to add grades 5 and 6 to our average calculation. And lastly, we'd have to add 2 more single-sided if statements to see if the 2 extra grades were above the average. Now think about making those same changes for a student that wanted to do this code for all 36 courses they took in their entire diploma program. That would be a lot of redundant code, but thankfully we can fix this and make it better by using an array to store all of the grades. So let's take a look at what an array is, how we create one, and then how we can use it. An array is a single variable that references a list of values instead of a single value. For example, when we create a primitive variable, it holds a single value. When we create a string variable, it also holds a single value, but it's the memory address of the string object in memory. Arrays are stored in a similar manner to objects like strings. First, we have to create the variable that will reference or point to the array. Here I'm declaring a variable called numbers, and you can see by looking at the syntax of the statement, its data type is int, but I have these extra square brackets there. That signifies that this is an array and not a simple int variable. So this statement creates the array variable numbers in the stack. Note that we use the square brackets, as I said, to identify that this is not just a regular int variable, but it's an int array variable. In Java, square brackets are used for arrays. Now this will vary from language to language. In some languages, they use parentheses instead. This is something that you'll have to check whenever you learn a new language. It's totally normal. Once you create the array variable, you then need to create the actual array. We do this by defining the type of data the array will contain and then allocating storage for a certain number of memory locations. So this statement now creates a new array of ints and allocates enough storage in the heap for 8 integers in this array. Each item in the array is called an element, so this statement creates an array that has enough storage for 8 int elements. The address of the first element is then placed into the numbers variable. Note that an array is automatically initialized with null values. So in this example, every element of numbers contains the int value 0. Now, to access an array element, you need to know that element's index. The index is the numeric position of the array element, where the first element of an array is always indexed at 0. The second element would therefore be 1, the third element would be 2, etc. So the last element is always indexed as the number of elements in the array minus 1. So our array numbers has 8 elements, and they are therefore indexed from 0 to 7. Now, if you wanted to place a value into an array element, you can use a normal assignment statement. But you must specify the element's index inside the square brackets. In this example, I'm taking the array numbers, element 2, so that's the third element, and I am assigning it a value of 25. So again, this places the value 25 into index 2, which is the third element of the numbers array. Now you can also initialize an array as you declare it using a slightly different syntax. This statement here creates a variable called grades and allocates storage for 4 doubles, and then it assigns double values to each element in the array. The number of elements in the array always corresponds to the number of items. And notice that the items are comma delimited. In other words, they separate the items by using a comma, and of course we add the space to make it readable. This works with any type. So you can do this with doubles, ints, you can even do this with strings. I'll show you an example actually of initializing a string array a little bit later in this video. You can also read an individual array item by its index. For example, if I want to print the value inside the third element of numbers, I can just refer to numbers index 2. However, usually you want to iterate through an array or loop through an array, and this is actually really easy to do with a for loop. Every array has a special property called the length property. It always contains the exact number of elements in the array. For example, if I was to do a print of numbers.length, it would print 8 because there are exactly 8 elements in the numbers array. This means you can use the length property in your for loop. Here I have for int I equals 0, I less than numbers.length, I plus plus, and inside, in this case, I'm just grabbing an int from the user and storing it into the corresponding element of numbers. Note the following important details about this example. We must start the loop counter at 0 because the first element's index is 0. The loop condition is I less than numbers.length, not I less than or equal to numbers.length. Remember that the last index is always the number of elements minus 1, or now we can say numbers.length minus 1. So if numbers.length is 8, then the last index is 7. So we want to iterate until the loop counter I reaches 7. So our loop would iterate for 0, 1, 2, 3, 4, 5, 6, and then one more time for I equals 7. And at the end of that iteration for 7, I will then be incremented to 8, and then the condition I less than numbers.length or I less than 8 would no longer be true, and that would cause the loop to terminate, which is exactly what we want. If you try to iterate past the last element, you will actually see an exception. When you run your program, it will compile fine, but the program will crash and you will see an array index out of bounds exception. I'm actually going to talk about that later on in the course in another video. If you're reading the values in the array, it's actually more efficient to use Java's for each loop. This is a special kind of loop that's specifically made to iterate arrays and other collections. The loop header needs to know the name of the array that you want to iterate through. In this case, it's numbers. You don't use the square brackets when you're referring to an entire array as a whole unit. We also need to create a special variable that will contain each array element for each iteration of the loop. In this case, I used int n. So this loop says, for each element n in the numbers array, print the value inside n. Whenever you want to refer to the current array element, you use the variable n, or whatever you defined in your loop header. So whatever parameter or variable you declared here, that's how you refer to each element of your array during a loop iteration. So for this first iteration, n is the first element 14, or the element at index 0. Inside the loop, the current value of n, which is 14, is printed. For the second iteration, n is the second element 25, or the element at index 1, so then 25 is printed. For the third iteration, the third element at index 2 is printed, so it prints 25, etc., etc., etc. And it works its way through the entire array and will automatically stop after it processes the last element. Now, it's always more efficient to use this for each loop whenever possible. If you're reading from the array and not writing to it, this is the loop that you should use. Unfortunately, in Java, you can't write to the array using a for each loop. You can in other languages, but not in Java. So if you're iterating an array to assign values to it, you have to use the regular for loop. Try this programming exercise. Create an array to hold 5 integer values. Write one loop to fill the array with user inputs. If a user inputs a value that's not a valid integer and will allow negatives, that's okay. Keep asking until they enter it correctly. After you fill the array, write a for each loop that prints the array elements all on a single line with a space between them. Go ahead and pause the video, give the exercise a try, and then I'll show you my solution. So I've already got a program set up, and I've already gone ahead and created my scanner. So what I want to do is, the first thing that they asked us to do was to declare an array that holds 5 integer values. So I start off with int. Don't forget the square brackets. It's actually a common mistake. Even I do it all the time. We forget the square brackets by mistake. And then the name of the array, I just copied the version on the slide. So I just use numbers, and then equals new int. And then in the square brackets, I allocate storage. We said 5 elements, so I put a 5 in there. You cannot declare the array and leave the allocation empty. You have to specify the number of elements. I'm actually going to talk more about that later in the video. So the next thing I want to do is I want to write a loop that takes each array element from the user, but I need to make sure that they enter a valid integer, and I am going to allow the positive negative sign in my input as well. So I'm going to have some repetitive code, and I'm going to add the loop part a little bit later. I'm just going to get the insides working first. So the first thing I'm going to do is ask the user to enter a number. So enter a number. And then I'm going to grab it as a string because I want to validate it. There we go. And then the next thing I want to do is I want to make sure this is valid. I'm going to start off with an if statement. So I'm going to make sure num is valid. So I'm going to check and see if num.matches. I don't need to create pattern and all that because I'm just going to do this one time. And I want to make sure that they have an optional, either a negative or a positive sign. So either one of those is fine. It may or may not be there. And then at least 1 digit. So that's my regex pattern. I'm just going to get all this in here so I don't forget. So if it does match, then I know that I can parse it safely into an int and then place it into the numbers array. That means that since I want to take my value and put it into the current element of numbers, I don't know yet what this is going to be. I'm going to have to fill that in. It's going to depend on what kind of loop I use, right? So I want to take my number and parse it. Integer.parseInt num. I'm not worried about like, is num greater than this or less than that, so I'm just going to go ahead and parse it and drop it right into my array, but I'm going to have to come back later and figure out what element of numbers it's going to go into. And then in the else block, it's an error message. Whoops, I pressed tab and I didn't need to. So a nice error message, error, you must enter a positive or negative whole number. Oh, Wendy, this isn't NetBeans. You have to break your strings yourself. I'm used to editors where they do that. That's okay. All right, see, that wasn't hard. Okay, so this is the code that I want to repeat. I want to repeat this code. The question is, how many times do I want to repeat it? So you might first be thinking, well, we're working with an array, we should use a for loop. But not necessarily, because if I put this inside a for loop, then it's going to obviously execute 5 times. I don't want to execute exactly 5 times. I want to get 5 correct inputs, but that doesn't mean this loop will execute 5 times because the user could input a correct value. I would count that one. But then they might enter an incorrect value. I won't count that one. So then they're going to enter a correct value again because I'm going to tell them they did it wrong. So that's 3 inputs so far. And then they enter, a bunch more correct values. I only want to count the number of correct things. So the ones they enter incorrectly, I'm not counting. So what I might do instead is use something like either a while loop or a do loop, an indeterminate loop, because then I can say loop as long as this specific condition is true. It doesn't necessarily have to be exactly 5 times. I want to say loop as long as I haven't reached 5 correct answers yet. So what I'm going to need to do is start with, I like using the do loop when it's user input. I just find sometimes the do loop is easier. In this case, it is. So I'm going to do a do loop. And then what I'm going to do, is I'm going to ask the user to enter a number, and then I'm going to check. If it's correct, then I place it into my numbers array, and that's going to count as one valid input. So what I want to do really is keep track of the number of correct inputs, and when that reaches 5, that's when I'm going to quit my loop. Now, that number I can use as my index, because remember, I haven't figured out what to use for my index yet. So what I can do is I can go outside my loop and create, I'm just going to call it index, create a variable called index and initialize it to 0, because that's going to be the first element that I want to access. And then what I'll do is if the user's input is valid, I will parse that input into an int and place that into that index. So for the first iteration, it'll be 0 of my numbers array, and then I will increment the index. But I'm only incrementing index as long as this matches. If it doesn't match, I'm not incrementing it. So that means at the end of my loop, my while condition is going to basically say loop as long as I haven't reached 5 correct numbers yet. So as long as my index variable is less than 5, not less than or equal to, because remember it starts at 0, 0, 1, 2, 3, 4, and then we want to stop, right? We don't want to get on 5 because that'll cause an array index out of bounds exception. So while my index remains less than 5, I keep going. So when the user enters, I think we just did one with a correct value. So the user enters a correct value, we add it to element 0, and then we increment index to 1. Of course, we skip the else. Is the index of 1 still less than 5? Yes. We loop back up to the top. We ask for the next number. So they enter something, let's say they enter something invalid. So does this match our regex? Let's pretend it doesn't. So we're going to skip to our else, print an error message, and index is still 1, which is because we haven't changed it, which is still less than 5. So we loop back up to the top, ask for a number again, and let's say this time they get it right. So is it correct? Yes. So this was a 1. So we put the next value in index 1, which is the second element, and now we increment our index to 2. So the index only gets incremented when the user enters something correct, because that's when we place that correct thing into our array. If we give this a try, we want to output our loop after so we can actually see if it worked. So after our loop, we want to do, I'm just checking the instructions, a for each, that's what I figured. So I want to do a for each loop after the loop. So what we have to do is we're iterating through the variable numbers. So I need to create a parameter that's an int. The parameter, or this variable that you create, must be the exact same type as your array type. So since numbers is an int, then my little parameter, or my variable n, has to be an int as well. You don't have to call it n. Some programmers actually like to call it I. It doesn't actually matter. Me personally, I generally will use the first letter of the array name unless the array starts with an L, because then in some fonts it'll look like a 1 or an I, and that's confusing. So I won't use an L. If it starts with an L, then I'll just use N or something else, like a D for double, S for string, etc. So here I'm just going to use N, but N can be anything, any valid identifier. And then I'm just printing it with a space. It said, whoops. So system.out.print, I'll do a printf, and then %3d. That way I'll get a space, because it'll space them all out nicely. And again, we want to print the current element of the iteration, which is stored inside the variable n. So I'm going to save and compile. and see how that goes. So compile, and so far so good. Execute. Okay, so we're going to enter, let me just make this bigger. So I'm going to enter a number, so I'm going to try something invalid. So I'm going to just type a letter S, and it says, error, you must enter a positive or negative whole number. And we are allowing negatives, so -2, that's good. 0, that's fine, but if I enter 2, because I'm a smart ass, nope, must be positive or negative whole number. How many valid ones have I done so far? 1, 2. So this would be my third valid one, and my second or my fourth valid one because I can count. And just for good measure, I'll do, boo for the last one. Nope, gotta be positive, negative value. 10, so that was 5 valid values, and there they are. Oh, I need to do a new line after my last line of output. But other than that, looks good. So just one quick fix, always make sure your last line of output ends in a new line. It's just a good idea. Just a blank print line will be fine. Another good way to test this program is if you just go invalid thing, valid number, invalid thing, valid number, invalid thing, valid number, invalid thing, valid number, invalid thing, valid number. That way we know it works every single time. Look at that. That's so much nicer. There we go. Now you can create an array of strings too. String arrays are initialized a bit differently from primitive type arrays. To see what I mean, let's try an example. I'm just gonna take this out. You can keep yours. I don't need mine because I already have it written down. So let's say I create a string array called values, and it's going to contain 5 strings. Remember, string is uppercase S. And then I'm just going to do a quick for loop for each string v in values. And I'm just going to print it. And we'll see what happens. Print line. V. There we go. So for each element in the values array, I'm just printing it on the screen and that's it. Nothing too exciting, but the output is kind of exciting. This is what I get. Let me just get these both on the screen. So when you create an array of string objects, you get null, 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 null. Now we talked earlier about how when you declare an array, it's automatically initialized with its null value. So you might think, well, shouldn't a string array be initialized with a bunch of empty strings? In other words, null strings? No, because strings are objects and that's not how objects work. Now some of this is review. I've talked about some of this before, but let's say, for example, I create a string variable S and I assign it hi. Like that. So we know from past experience that that creates this variable S, but in the stack, and then in the heap area of memory, it creates the string object, and that string object has a little value property, and that value property contains the actual value of your string. And there's other things in here. There's methods. We're actually going to learn about these methods in the next video. So there's methods and stuff, and that variable points to the address of this string. So if this string object is stored at address FF00, that's what's actually inside this variable S. So that means if I create a string variable A and don't actually give it a string object, then it's just sitting here A and it contains null. Null means it's not pointing to anything. So when you create your array of strings, right, so this time we've got a string array, what you're creating is a whole bunch, and this, I think there was 5, 1, 2, 3, 4, okay, well now I got 6, but we created a string array. They basically are all these. So they're all little null. So they just basically all have null. They're not pointing to anything. When I take my string array, I called it in the example in the code values. If I was to now take, say, values element 5, because I added an extra one by accident, so that's the element 5, and I assigned it hi, then what that actually does is it creates the string object in memory. Sorry, my writing's getting really messy here. I want you out of the way here. So it creates the string object with the value hi. And if that is stored at FF22, that's what's actually put in here. So this array element is pointing to this object in memory. So that means that values 5 is actually a memory address and not an actual value like we saw earlier with the integer and double arrays. But that's okay. That's the way it works. This is the way it works for all objects in Java. If for some really weird reason you wanted to create an array of scanners, it would look exactly the same. Each element is actually a memory address pointing to a scanner in memory. So remember that strings are objects, and therefore when you create an array of strings, it's initialized to this null, which means no object in here. It means the element's technically actually empty, and there's no object. It's the object equivalent of a 0, like you might have a 0 for an int. Not an empty string. An empty string is different. An empty string would be an actual string object with nothing in the value property. Now, if you wanted to initialize a string array, you totally could. You could, instead of doing, let me just comment this out. If you wanted to, you could initialize a string, just like we initialized the doubles array earlier. I think we did it with a double array. So if you wanted to, for example, create and initialize a string all in one shot, you could do that. Or if you had a string array that was created, I'll do a different string array this time, so I'll just call it inputs and equals new string, however many elements you want. Then you could write a for loop. Now I can't use a for each loop here. I would have to use a counted for loop because I'm writing to the array. So inputs.length and then I++. And then I could initialize it inside the loop. I could initialize it with, you know, whatever. Maybe in this case, it would make the most sense if I initialized each element. Notice I used the counter as the index with, let's say, a scanner's, you know, next method. So what this example, I'd have to create the scanner, obviously. But this example would, assuming I had a scanner, you can just copy and paste from one of your previous programs if you want to try this out. That would get each user input, and every time the user inputs something, it would store that word into one of the elements of the inputs array. In fact, if we want to try this out, we can totally do that. So I'll just really quickly create a scanner. Like that. And then just so we can see it, it's kind of redundant to create two loops for this example, but again, it's just an example. And then just a quick system.out.println s. Again, this isn't all that exciting. It's going to allow me to input. There's no prompts, by the way, so hopefully the user would know what they were doing. Let me just get that up there. So I'm going to go through this first loop. There we go. Where it's basically, I didn't add any prompts. So it's basically waiting for me to type something. So I'm going to type in hi, bye, boo, foo, moo. And then it stops, and then it just regurgitated, that's the second loop, it just regurgitated my inputs back on the screen. There you go. Most of the time in this course, though, we're probably going to work with numeric arrays like ints and doubles. Although I am going to give you an exercise a little bit later that works with strings and chars, but most of the time we'll be working with doubles and integers. Now there's lots of practical uses for arrays. One of my favorites is something we call a frequency table. And a frequency table keeps track of the frequency or number of occurrences of something. For example, you might want to keep track of the number of times you've watched each of the Harry Potter films in your lifetime. Every time you watch one of the films, you would then add one to the count for that particular film. So like the other day on TV, The Half-Blood Prince was on, so I watched it. And then I add one to the number of times I've watched the 6th Harry Potter movie. So that happens to be one of my favorites, which is why it's the largest one. So let's create a frequency table that keeps track of the frequency of random numbers from 1 to 10. First, we'll generate 100 random numbers from 1 to 10, and then we'll keep track of how many 1s we generate, how many 2s we generate, how many 3s, etc., all the way down to how many 10s we generate, and then we'll display the contents of our frequency table. So how will the logic work for this program? Well, if we did this manually, we'd set up some boxes or some lines on a piece of paper where we could keep track of how many of each number we get. Then we generate a random number. So let's say, for example, we generate the number 4. So we go to where we keep track of the 4s and we add a tick mark or a 1. There we go. We've got 1, 4. Then we get our next random number, and let's say this time that random number is a 9. So we would go to the 9s where we keep track of the number of 9s, and we'd add 1 to that. So now we have 1, 9. And then let's say we get another 4 again. So this time we have to go to the 4s. Now we have 1 4 so far, and we're going to add another one. So now we have 2 4s. Then we generate another random number, and let's say, ooh, we get a 4 again. So we go to the 4s, and we add another one to the 4s, so now we have 3 4s. The next random number, let's say it's a 2. So we go to the 2s, and we add 1 to the number of 2s that we have so far. So we would continue this 100 times because we want to generate 100 random numbers, and we would keep track of how many of each value from 1 to 10 that we generate. And after we've done 100 numbers, the boxes will contain the total number of times that each number was generated. So for our application, we need to loop 100 times to generate 100 random numbers, and then we increment the array element that keeps track of that number that was generated. So let's try coding it. So the first thing we have to do is we have to create our array. Now the array will only have 10 elements, one element to keep track of each value from 1 to 10, not 100. We're not keeping track of 100 numbers. We're only keeping track of 10 numbers. So I'm going to create an int array because we are counting. So this would be an int array. We can't generate a half a value. So I'm going to call it frequency, spelled correctly. And it's going to have enough storage for 10 integers. There. Now we need to create the loop that generates the random numbers. This you can still use a for loop, but it's not going to iterate for the number of elements. It's actually going to iterate from 1 to 100 because we want this loop to iterate 100 times. We want to generate 100 random numbers, and then each number we're going to have to keep track of which element we want to increment. So inside the loop, the first thing I'm going to want to do is generate one random number between 1 and 10. So I'm going to use the random number formula that we've used before, times 10 plus 1. Not 100. Sometimes when I do this without thinking, I put a 100 in there instead of a 10. We are generating 100 numbers, but we're only generating a number between 1 and 10. So all of these 100 numbers are going to be between 1 and 10. It should make sense. That means we're going to get some of these numbers occurring, or probably all of these numbers occurring more than once. Now inside the loop, after we generate a random number, we now need to find the appropriate element of the frequency array and update it. So for example, if we generate a 4, I want to add 1 to the 4th element of our frequency array, which has an index of 3. If we generate a 9, I want to add 1 to the 9th element of our array, which is going to have an index of 8. So that means that the element that we want to update is n minus 1. So whatever number n I generate, I subtract 1, and that's the element that I want to update. So I'm going to use that as my index to frequency. So I'm going to take frequency n minus 1. So again, if I generate a 4, this is going to be element 3. Perfect. And what do I want to do to it? I want to increment it. That's it. So just frequency n minus 1 plus plus. That's it. Now we can test it out, but we can't tell what's in the actual array when we're done. So we're going to finish it off by adding the for each loop that prints the contents of each element. Because this time I'm reading the array, I can just go ahead and use a for each loop frequency, just like that. You can use a counted loop if you wanted to, but again, if you're reading an array, it's actually more efficient to use, I can do a print line here, to use the for each loop. Like I said before, you should use the for each loop whenever possible because it is more efficient. Even if you need the counter anyway, you'll see one of the later examples where we need the counter, or we could even do it here. Even if you need the counter anyways, you should still create a counter and increment it. It is still more efficient to do that using the for each. I'm actually, you know what? I'm going to do that. Let me just get this working first so we can make sure it works. There we go. So there's my output. Now, don't freak out if your numbers are different. It's so funny when I actually do this in the regular classroom, face-to-face. I usually get at least one person that's like, oh, mine's broken. It's not giving the same numbers as yours. That's because it's random, so they're not going to be the same, obviously. So yeah, your numbers are going to be different, but as long as you have 10 of them there, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So as long as you got 10 numbers, you're good. Now, let's say I wanted to make my output say like these are the 1s, these are the 2s, these are the 3s. We can do that. So it is more efficient to use a for each loop even if you have to add a counter. A lot of people say, oh, as soon as I need a counter, I'm going to use a regular counted for loop. Nope, it still is more efficient. So if I create a variable index equals, and I can initialize it to 1 because I'm not actually using it as an index. What I'm going to do is use it to say like the 1s, the 2s, the 3s, etc. So I'm going to make a little printf, and I'm going to do a percent, 2d, that's going to be like the 1s, the 2s, the 3s, and then a colon, and then a space, and then the percent %d for, I might as well format that too, the percent %d for the frequency value, and then I need the \n on the end of that. And I'm going to replace this with my index. And that means I'll have to increment my index after I'm done, but you know what you can do? I do this all the time. Remember, if you put the plus plus after, it's going to print this stuff first, and then it will increment index. So it'll increment after, so that way you still only have one line of code inside your for each in case you want to take the brackets off or the braces off. There we go. So let's give that a try and see if it looks okay. So I'm going to compile and execute, and oh, it's looking good. Let me just stretch this up here a bit so you can see. There we go. Oh, look, it's all nice and formatted, and everything is lined up at the tens column, which is perfect. There we go. So there's my frequency table. And yes, the numbers are different because it's random. So there's another look at the code one more time. This is actually one of the exercises in the notes. So you'll see there's actually a solution to this. It might be slightly different, but the logic will probably be exactly the same. Now, one more important thing to note about arrays in Java, and that's that once you declare an array and allocate storage, you cannot change the number of elements. You're basically stuck with it. So however you decide to create an array, whether you construct it and then assign a number of elements, or whether you declare it and initialize at the same time, you cannot change the number of elements. You will always, in this example, have 4 elements in this array. No more, no less. So for example, you would not be able to write a statement like this one where I go to the next element, right? So that would be the 5th element, index 4, and assign it a new value. You cannot do that in Java, not with a regular array. So this is one of the disadvantages of regular arrays in Java, but it's one you can get around in term 2 when you learn about Java's collections framework. Now, if you're impatient and want to find out how to create dynamic arrays in Java, you can check out the chapter in your book on ArrayList, the ArrayList class. I think it's chapter 11.11, so section 11 of chapter 11. But again, we're not actually doing that in this course. You'll be doing that in semester 2. Now this means, of course, that you need to know the size of your array as soon as you're ready to allocate storage. So this can cause problems for programs where there's some unknown number of elements. For example, what if we want to redo the grades program, but for different users, all of whom are taking different numbers of courses? So one solution would be to ask the user first for the number of courses they're taking, and then use that input to declare the grades array. And of course, you'll want to validate that input first. So that brings us to the next exercise. Go to that grades program, the pseudocode that we saw at the very beginning of the video, and rewrite that program using an array of doubles. Ask the user for the number of courses first, and then use that to allocate storage for your array. After you've collected all the grades, display the average, and then display the indexes of the grades that are above the average. Go ahead and pause the video, give that a try, and then come back and I will show you my solution. Okay, so here's the solution that I came up with. So I create my scanner, I create an integer variable for the number of courses, and then I start my do loop. This do loop is the validation loop for the number of courses. It's actually the exact same thing we saw in the validation video. So inside the do loop, I ask for the number of courses and I grab it as a string. If it does not match my regex, I print an error message and move on. I set my while loop to continue while the number of courses variable is invalid if it's less than or equal to 0. So since I initialize it to 0, which is an invalid value, if it does not match the regex, it's never changed or incremented or anything. So by the time I get back down here, it's still less than or equal to 0. So that'll cause my loop to reiterate. But on the other hand, if they enter one and it does match the regex, so that if block is skipped and we go to the else, then it parses that value into an integer because it's safe to do so. If the integer value is less than or equal to 0, So if they enter 0 or a negative number, it prints the error message, and since it's less than or equal to 0, that'll also be true, the while loop condition, and cause it to go back up to the top. So I didn't have to create a Boolean flag for this one. I just used numCourses less than or equal to 0. But if the user enters one that does match the regex and it is greater than 0, then the loop terminates because numCourses is no longer less than or equal to 0. So by the time that loop is finished, I have a valid number of courses, and I can then use that to declare and allocate storage for my grades array. Once that's done, I then set about calculating the average. So this is pretty standard. We've done this before. So I set up a total grade variable for each item in my grades array, or actually, instead of using grades.length, you could have also said numCourses. Both are fine. Length is a property, it's not a method, so it's not any more or less efficient than using numCourses. It's probably just going to come down to a matter of what's fastest to type for you. So either one of those is fine. So for each item, or for each course, if you will, I'm going to, and look how I actually displayed the course number, so 1, 2, 3. I used the loop counter, but the loop counter goes 0, 1, 2, so I had to add 1 to it. So that way, the first iteration, it'll show a 1 and not a 0. It's just more user-friendly that way. So I say enter course 1 grade, course 2 grade, etc. I didn't have time to validate, but ideally you should. You should make sure that the grade they enter is valid, so I just went ahead and skipped that part. So I grab it as a double and I put it right into the proper element of my grades array, and then don't forget to add that to your total before you move on and get the next grade. Once that loop is finished, I then have a total. So the total is the sum total of all the grades that were entered. I can divide that either by grades.length or by numCourses. Again, either one is fine. Both of them contain the same number if you did everything correctly. That calculates my average grade, which I then print my average grade. Now, we're not done. I now have to go back through all of the grades that I previously entered, and I have to check and see which ones are above the average. So for each grade, I see if that grade is above the average, I print its index, and then I have to increment the index regardless. Don't put the index plus plus inside the loop or inside the if like we did in one of the previous examples. You have to increment the index every single time. And I do that because I need the actual index. Again, it is more efficient to create the index and use a for each loop than it is to use a counted loop. I know it sounds silly, but in semester 2, when you learn about iterators with the collections framework, you will see why that's the case. But just trust me, it is. And then I just had to finish with a print line so that my last line of output ended in a new line because I was using printf inside my loop. So that is already saved. So if I compile and then I execute, I'm going to test it out. So I'm going to say 84. I just said 84 courses. That's not what I wanted to do. I'm just going to kill that and start over. I did that 5 minutes ago. I don't know why I did that again. So that's what happens when you don't read the screen. So how many courses? 3. So I'm going to enter my first grade 85, and then I'm going to enter 86, and then I'm going to enter 87. That should give me a nice round average of 86. And it says grades above average 2. That's the index of the grade that was above the average. Only one of them was above 86, and that was the third one, so it prints index 2. If you had more than one above the average, you would see them in a list. Perhaps I should do an example where there's more than one. I'll do 5. 86, 87, 88, 89. There we go. So 3 and 4. So grade number 3, which is grade or index number 3, and index number 4, which is grade number 4 and grade number 5, are above the average. There we go. Okay, I want to try one more exercise before we go. Let's write a program that asks the user to enter a phrase and then copies that phrase letter by letter into a char array. So for example, if the user entered Java is cool, then your char array would contain JAVA space IS space COOL. So one character, including the spaces, in each one of the char array elements. Now here's a tip that's going to help you out. In the string class, there's a method called length. It's not a property like it is with an array. It's actually a length method. If you execute the length method on any string object, it will return the number of characters in the string object. So go ahead and pause the video, do the IPO chart and sketch out the logic, and then write the program. Then resume the video and I'll show you the answer. Okay, so hopefully you had a chance to give that a try. So our IPO chart. So the output for this program, we're just going to output the contents of the char array so we can see that it worked. The input is just a simple phrase from the user, which means we'll have to use the next line method to get that. And then the processing, we want to create a char array that has the same number of elements as the number of characters in the input string. That's where we're going to use our length method. And then we're going to copy each character from the string array into an array element. So this obviously is going to be the part that uses a loop. So for the logic part of this part here, I'm basically going to say for each character, and we're thinking, how have we done character in a string? Oh, we can use char at, right? So for each char at in our string, we then want to take our char array and we want to assign it one of these letters. So we're going to take each char using char at and put it in one of the elements of our char array. So let's code it. So here's the solution I came up with. So of course I'm going to need a scanner because I have to ask the user to enter a phrase. So there's the phrase that they enter. So I'm going to store it in this variable phrase. You have to use next line because a phrase has multiple words. So we got to make sure we get all of the words they enter. And then what I did was to create my char array, which I just called letters, but if you called it something else, that's okay. So I created letters. And then what I do is I allocate enough storage for each character inside my string. So I take the phrase, which is the string, invoke the length method. So again, if it was Java is cool, that's 12 characters because it includes the spaces. So that would put a 12 in there. So it would create a char array with 12 elements or enough space for 12 chars. So whatever the user types, you're always going to have the right size of char array. And then I have to use a counted loop here. You can't do this next part with a for each. So what I did was I went from 0 to letters.length. Now you could also use phrase.length, but in this case, length is a method, so it's less efficient than using letters.length. So in this one, I would use the letters.length and not the phrase.length. The property, it's like a variable. It's easy to access, but using the method, it's not good to call a method more than once to get the exact same value. If you need the value more than once, then you call the method once and store it in a variable, and then use the variable everywhere. So here I didn't need to do that because I can just use letters.length. So it is better in this case to use letters.length. And then what I do is for each element, I basically use char at I. So I is going to be 0, and then 1, and then 2, etc. I use that as the char at argument or input. And that's going to give me a char, a character, at that position. And I'm going to store that in the corresponding element of the letters array. And then after that, just so we could practice, it's kind of redundant to print this way, but we just want to practice. So for each char in the letters array, I printed, I don't know, we haven't done this for a while, the %C to print a char. It's been ages. It's been since like week 2 or 3, I think, that we've done that. So I'm just printing a char and then make sure your last line of output ends in a new line. So if I save, compile, and execute, and I type in Java is cool, and I added spaces around my chars. I don't know if you noticed that, so that way I can tell the difference between the input and the output. So there we go. Java is cool. Now, you're going to hate me for this, but there is actually a shortcut to this question. You didn't have to do it with a loop, but we're not going to learn this until later. Actually, I think in the next lesson. There's actually a method that does this code for you. You could have actually, if you instead did take your string phrase, and there's a method called toCharArray. That's it. So, whoops. That's actually, that one line of code replaces those lines of code. It does the exact same thing. But if we had done that, then we wouldn't have gotten to practice with loops, would we? Oopsie. Except I named it incorrectly. Letters. There we go. Let's try that again. All right. See, this was better practice with loops. So if I say Java is cool, it gives me the exact same output. So that one line that calls the toCharArray, oops, I missed the X there. toCharArray, it actually does this code. It does the exact same thing. But, you know, it's no fun if I give you the easiest answer, is it? So we practice for good reason, right? Speaking of practice, if you want more practice with arrays, there are a few questions in the web notes for this lesson, and there's lots of questions in the textbook. So if you go to the last sections of Chapter 7, you'll find several programming projects and a whole collection of different questions that you can try as well. So that's an introduction to arrays. In the rest of this course, we'll use arrays and loops to solve some kinds of problems. And in the second Java course next term, you'll learn even more about arrays, and you'll also learn about Java's collections framework. But that's it for now. Thanks for watching.